Today we will discuss about temperature and the pressure sensor belongs to transformer oil, which is in circuit of transformer oil circuit. As you know, conventional locos does not have such sensors, but three-phase locos having temperature sensor and pressure sensor for transformer oil. This is the temperature sensor. Temperature sensor is used to measure the temperature of the transformer oil. When the loco works, the transformer will get heated up. So the system should know at what temperature the system is working right now. The temperature sensor we are using is a PT100 one. PT100. Why PT100? That I will tell you later. Then positive temperature coefficient, which means the temperature sensor is having a resistance. When the temperature increases, the resistance across the temperature sensor also will increase. That is why it is positive temperature coefficient. Then in a single sensor, this is a single sensor. In that single sensor, there will be two elements. Okay. Operating temperature, this sensor can take readings from minus 45 degrees to minus 45 degrees to plus 125 degrees. Then, as you know, as I said, there are two elements in a single sensor. So we can allow maximum 0.4 ohms difference between two elements. This is the PT100 chart. Why it is called PT100? Because when the temperature is at 0, the resistance will be 100 ohms. That is why it is called PT100. This is the PT100 chart. This is the zero temperature. I will go to the next page. See, this is the 0 and this is also 0. So this is the 0th position. If you want to know the temperature of the 1 degree Celsius, you have to look at here 0, 1. It is 1. Okay. If you want to see the temperature at 35, resistance at 35 degrees Celsius, you have to look at 30, then 5. So it will be 113.608 ohms between that element. Okay. In the two elements, you can get these values. That values should be equal, or it can go up to the maximum of the difference of 0.4 ohms. Next is the pressure sensor. Pressure sensor is a piezoelectric item. When the pressure is applied to that piezoelectric crystal, the resistance of the piezoelectric crystal will vary. Accordingly, the current flowing through the sensor will change. The pressure range of that pressure sensor that we are using is 0 bar to 4 bar. Okay. That is a output. The temperature, the pressure sensor is connected in the transformer pipeline. So it will get heated up, it will get cooled down over the time. So the output should not vary according to the temperature. So the outputs are temperature compensated. Okay. The supply voltage is 18 to 30 volts. For this to function on supply we should give on supply, that should be in between this range. In our loco, the supply is 24 volt. The output is 0 milliampere to 20 milliampere. It is exactly linear to the pressure. As the pressure increases, the current will increase. It is exactly linear. This is the applied pressure and the output current that we can get from that sensor. If the pressure is 0, if there is no pressure, we will get 4 milliampere from that sensor. If the pressure increases, 1 bar, 2 bar, 3 bar, that will increase. The output current also will increase. At 1 bar, we will get 8 milliamperes. At 2 bar, we will get 12 milliamperes. 3 bar, 16. 4 bar, 20 milliamperes. That's the maximum limit. At 4 bar, we can get 20 milliampere. This is the cooling concept of three-phase loco, transformer and traction converter. Okay. So these are the locations where our sensors are connected. Okay. In a three-phase loco, there are for oil cooling circuit, there are two temperature sensors, temp 1 and temp 2. Okay. One is connected at oil pump 1 circuit, another is connected at oil pump 2 circuit. That is temperature 1 and temperature 2. And there are 4 pressure sensors. One is connected to the input of radiator 1, and one is at the output of radiator 1. Similarly, there is one at the input of radiator 1, the output of radiator, means radiator 2, output of radiator 2. So we will call as P in 1, that is the input side of radiator 1, and P in out means that is the output side of radiator 1. So these are the pressure sensor locations. I hope you can understand by this diagram. This is a transformer. Oil will be pumping by a oil pump, MPH. It will go through the radiator. It will pass back to the transformer. So that radiator is cooled by OCB1. The other side is exactly same. There is no difference. So in the SR, for SR, one pump is there. It will circulate the coolant through the radiator. The radiator is sandwiched type. The top one radiator is there for coolant. Bottom one radiator is there for transformer oil, and same OCB is cooling is both the radiators. Okay. So these are the locations where the sensors are connected in the system. Okay. Now let's talk about ventilation logic. What is ventilation logic? Ventilation logic means we don't have to run the OCB in full speed all the time. We can decide when the OCB should take full load, when the OCB should shut down. Okay. So basically OCB is connected to bar 1. So this is the ventilation logic for ABB. That is all. This is almost similar for other make propulsion also. Ventilation level 0. That is, if the transformer oil temperature is less than 48 degrees, the OCB will not work. Bar 1 will not work. There is no ventilation required at that time. Ventilation means the running of OCB, flowing of air through the radiator. When the temperature reaches above 48, it will start ventilation level 1. Ventilation level 1 means the OCB will start at the low speed. At ventilation level, at the temperature reaches at 55, it will reach ventilation level 2, and above 55, the ventilation level will be 3. The OCB will run at full speed, that is 415 volt. 50 hertz supply will get to the OCB, and OCB will run with full speed. This is almost similar for SR coolant temperature also. Ventilation level depends on both these things. Okay, this is for transformer oil, this is for coolant. So correlation of these will be the actual ventilation demand. Okay. What will be the problem we will face in the loco because of this malfunctioning of the sensors? So we should know where these sensors are connected. This is the 12G of our three-phase loco circuit. This is the 12I page. Okay. In the 12G page, we can see one transformer oil temperature sensor. In that, 2 elements are there. One element is at the AB, and second element at the CD. E port is the earth point, and it is connected to SR. You can see the signal number SLG1, AMB, SB. This is the signal number. Okay, SLG1 means SR1. Okay, if you see FLG, it will be VCU. This is SLG, so it is directly connected to the SR. 2 channels will be reading by the SR. Okay, SR1. And for the pressure sensor, P in, pressure in and pressure out. 2 sensors are there. 2 sensors are connected to a differential amplifier because it should read the difference of the pressures, and it will fed it to the SR through an other signal called excited drug TR. Okay. So these are the signals. This pressure sensor should fed with a 24 volt power supply. So that supply will go from this SR to the differential amplifier. And the differential amplifier will relay this 24 volt supply to the both pressure sensors. This is the second page is exactly same. Only thing is that is going to the SLG2, that is SR2. So this is SR1 side, this is SR2 side. Transformer 1 side, that is transformer 2 side. You can get these pages in 12G and 12I. Okay. I hope you understand 12G and 12I. That is if you go to the three-phase loco circuit, there will be a page number for each and every page. This comes at 12G. Okay. So when will this fault will come? We can see the logic. I put the logic of MEDA propulsion, and BT also almost similar. ABB is somewhat different. So If the difference of the two elements, that is, I told you there are two elements in a single uh, sensor. If the difference in the two elements is more than 50 degrees, the lower value will be considered for DJ tripping. Okay, that is, if the value is one sensor is showing 30 and the another sensor is showing 90, then it will not trip. It will take lower value because 30 and 90 there is a difference of 50 or 60 degrees. So the lower value will be considered. The DJ will not trip. But in case the difference is less than 50, then the higher value will be taken. For example, if the one sensor is showing 40 and another sensor is showing 85, the difference is 45 degrees only. So it will take the higher value for tripping the loco. In that case, DJ will trip. In case of the temperature, for any element, if the temperature goes beyond 130 degrees, that element will be discarded. The lower value from the other sensor will be taken. That's the meta logic. These are some cases. So you can see in SR1 there are two elements. One is showing 40 degrees and another one showing 86.6 degrees. In SR2 almost same, 42 and 41 degrees. So as you can see, the temperature is around the 40 to 42 degrees only. But one sensor is malfunctioning. One element is malfunctioning. But the difference you can see that is 46.6. So it is within 50 degree difference only. So DJ will trip because the value reached beyond 40, beyond 84, and the difference is within 50 only. So this value will be considered for tripping the DJ. DJ will trip and the node will go to 710. This is another case. In this case, these are the same situation. Temperature difference is different. The value is correctly around at 50 or 51, but one sensor is malfunctioning. So in that case also, DJ will trip because the higher value is not much more than 50. The difference is maximum 42 only. So the higher value will be taken for tripping the DJ. The DJ will trip. This is the last case. The actual temperature value, three sensors are showing values almost correctly, 30, 31, 29. That will be the correct value of the transformer. But one element is malfunctioning. That guy is showing 125. So that's the difference is very huge, more than 50. So that element will be discarded. It will not, so in that sensor combination, both elements, only 31 will be taken because this is a very huge difference, more than 50. So the lower value will be taken for DJ tripping. So in this case, DJ will not trip, but one pop-up message will come. The message. What is the problem with this message? The message is F0105 P1. Actually, it should be P2 because DJ is not tripping. For every P1 message, DJ should trip. But the problem with the logic is there is no P2 fault for this kind of problems. Only P1 fault. DJ will not trip, but this message will come. The loco pilot will get confused and he will trip the loco and he will say P1 fault has occurred. Recently, one fault has discussed in the last FAM. This is the logic for ABB in version 54. I don't know what is happening in the latest versions. This is in version 54. SR1 and 2. Before version 54, the only one element will be taken for reading the values. But in 54, SR1 and 2 having two elements, both values will be taken. And tripping limit is 84 degrees. If one element crosses 84 degrees, nothing will happen. This fault will pop up. DJ will not trip. If both sensors crosses 84 degrees, then the message will pop up and DJ will trip. So that is somewhat more good method because there is no comparison between both elements if it is within 50 or out of 50. There is no such thing. One element crosses 84, it's okay. Only one pop-up will come and the loco will work. If both elements crosses 84, then that is the exact issue. Then loco DJ will trip. That's the correct logic. But in that case also, this pop-up will be coming like this only. F0105 P1. That should be changed. That was discussed in the last FAM. So we'll see the one case study for 30802 loco. See, you can see F0105 P1. It was logged many times, 35 times, 35 times. So many times it has logged, 34 times, 33 times. So much logging was there. But if you see the values, this is actually a BTL propulsion. The tripping value of BTL propulsion is 80 degrees. So if you see the values, the value reached 80 degrees. I hope you can see. Actual value is 39 because SLG 1 and 2 saying both SLG 1, temperature on SLG, temperature to SLG 1, and temperature on SLG 2 and temperature to SLG 2. That is SR1 temperature 1 and 2, SR2 temperature 1 and 2. Temperature 1 and 2 of the SLG 1 saying it is 39, and temperature 2 sensor of the SR2 is saying 39. That is the actual value is 39, but only one element is showing a faulty value. That is that sensor was showing was malfunctioning. But as soon as the value reaches the 80, the message popped. Message popped as disturbance in converter. This message. But DJ didn't trip. But loco pilot couldn't understand whether it is a P1 fault or P2 fault. He tripped the loco. In the same loco, in another occurrence, you can see the temperature was going beyond that level. All other sensors are saying 39, that is actual value, but this case, this guy was showing 101. So in this case also, this message has popped up. So this was the problem, because if it was a P2 fault, if it was showing as a P2 fault, the loco pilot will not get confused. He will just acknowledge and he will continue. But if it is showing as a P1 fault, but nowadays many loco pilots know the problem, so most of the problems will be avoided. But recently one loco failed account of this P1 and P2 confusion. In that loco, what we got is the B pin, A, B, C, D, E. The B pin having a loose contact at the crimping area of that leg. So we changed that leg. So this was the point. Temperature sensor A, B, C, D, E. So E is earth, A, B, this element. So the first element of that sensor and the B pin also having loose contact. So if the loose contact comes, what happens? This is the PT100 chart. If the loose contact happens, the resistance value will increase. If the resistance value increase, the system will detect as a higher temperature. So loose contact in the temperature sensor is a big issue that will create unwanted tripping. That's all. Thank you.